Dear students, now we are going to discuss waves propagating in rectangular waveguide. Let's start with the definition. Waveguide is a hollow metallic conducting tube of uniform cross section which is mainly used for propagating the electromagnetic waves. Here its shape is rectangular, hence it is called as rectangular waveguide. It is widely used because of its simpler form and low cost. This is the structure of rectangular waveguide with the dimensions A and B. Okay. So next we are going to derive the field equations of the electromagnetic waves propagating in this rectangular waveguide. Here we can consider that the wave is propagating in the Z direction. In order to determine the field components within the guide, we have to use Maxwell's equations with an appropriate boundary conditions. Okay, let's consider the Maxwell's first equation. Del cross H vector is equal to sigma E vector plus j omega epsilon E vector. This is the Maxwell's first equation. In this rectangular waveguide, within the waveguide, the region is non-conducting region. Correct? So here, the conductivity is 0. Then this first equation can be written like this. Del cross H vector is equal to j omega epsilon E vector. Consider this is the Maxwell's first equation for rectangular waveguide. As we all know that the curl function for this del cross H vector is represented like this. So del cross H vector is equal to x bar, y bar, z bar, dou by dou x, dou by dou y, dou by dou z, hx, hy and hz. So here x bar, y bar, z bar, these are representing the directional coefficients. So it can also be represented like this. Okay. So this side, this term becomes j omega epsilon. E vector can be written like this. Ex x bar, ey ay bar plus ez az bar. So here ax, ay, az, these are nothing but the directional coefficients. Okay, the same way we can represent like that. So next, for further simplification, we can expand this curl operation here. So x bar, this x bar is nothing but what? Ax bar, both are same. Okay, so here x bar, then we can cross multiply this thing. So dou hz by dou y minus dou hy by dou z. For the second term, we can write minus y bar dou hz by dou x minus dou hx by dou z. Similarly, we can get plus z bar into dou hy by dou x minus dou hx by dou y, that is equal to the right hand side is as such. Okay. So from this, we can equate the x, y and z components on both the sides. So here the x component is dou hz by dou y minus dou hy by dou z, that is equal to, what is the x component here? J omega epsilon Ex. Similarly, we can take the y components. Here we can consider this minus sign. Okay, so here we have to multiply this minus inside this for this y component. Then this term becomes minus dou hz by dou x minus into minus plus. So here the first term is what? Dou hx by dou z minus dou hz by dou x, that is equal to j omega epsilon Ey. Okay. Then the last one is z component, dou hy by dou x minus dou hx by dou y is equal to j omega epsilon Ez. Consider this as the first equation. Okay. Next we are going to consider the Maxwell's second equation. Del cross E vector is equal to minus j omega mu h vector. This is the Maxwell's second equation. Here there is no conductivity term, we can take it as such. Then expand this curl operation. Del cross E vector can be written like this. X bar, y bar, z bar, dou by dou x, dou by dou y, dou by dou z, ex, ey, ez. Then this right hand side we can write this h vector as hx x bar plus hy y bar plus hz z bar. Then we can expand this curl operation like this. So x bar, dou ez by dou y minus dou ey by dou ez minus y bar, dou ez by dou x minus dou ex by dou ez plus z bar, dou ey by dou x minus dou ex by dou y is equal to minus j omega mu hx x bar plus hy y bar plus hz z bar. Then we can equate x, y and z components on both the sides. we can get the value like this. Dou Ez by dou y minus dou Ey by dou Ez is equal to, this side the h component is what? Minus j omega mu hx. Similarly, we can take the y component. Here we can multiply this minus sign inside that. Then we can get dou Ex by dou Ez minus dou Ez by dou x is equal to minus j omega mu hy. Then the z component is dou Ey by dou x minus dou Ex by dou y is equal to minus j omega mu hz. Consider these three equations as the second one. Okay. As we all know that if the wave is propagating in the z direction, the amplitude of the wave is reduced by the propagation loss. So here the wave is propagating in the z direction, then the amplitude of the wave is decreased by the factor e power minus gamma z. Here gamma is nothing but the propagation constant. So here we can represent the field components Ex as Ex naught e power minus gamma z. So here this Ex is the reduced value, okay, in the propagation direction. Here Ex naught represents the amplitude. This is the factor which is reducing the amplitude, okay. Then next we are going to differentiate this Ex component with respect to this Ez, because the wave is propagating in the Z direction. So dou Ex by dou Ez is equal to Ex naught minus gamma e power minus gamma Z. If you are going to differentiate with respect to Z means we can get this value like this. We can write minus gamma Ex naught e power minus gamma Z is nothing but Ex. So we can write this value as minus gamma Ex. Similarly, we can get dou Ey by dou Ez is equal to minus gamma Ey. Dou Hx by dou Ez is equal to minus gamma Hx. Okay, so whichever field components are differentiating with respect to Z, those can be written like this. Next, we are going to substitute these values in the first and second equations. So from the first equations, we can take the first one, dou Hz by dou y minus dou Hy by dou Ez can be replaced with the value minus gamma Hy. That is equal to j omega epsilon Ex. So here minus into minus plus. We can consider this as the third equation. Okay. So these equations are very important one. So next we can take the second one. Dou Hx by dou Ez is replaced with the value minus gamma Hx minus dou Hz by dou x is equal to j omega epsilon Ey. Okay. Here we can take this minus outside and move that value to this side. Then we can write dou Hz by dou x plus gamma Hx is equal to minus j omega epsilon Ey. So this is the fourth one. Okay. Then the third one is dou Hy by dou x minus dou Hx by dou y is equal to j omega epsilon Ez. There is no change in this equation, but we can consider that as a fifth equation. Okay, so the first three equations can be written like this, third, fourth and fifth equations. So next we have to take the second equations. Okay, so in the second equations, take the first one, dou Ez by dou y minus dou Ey by dou Ez is replaced with the value minus gamma Ey is equal to minus j omega mu Hx. Here this term becomes plus. Okay, so dou Ez by dou y plus gamma Ey is equal to minus j omega mu Hx. Consider this as the sixth equation. Then the second one of the second equations we can take minus gamma Ex. That is, this dou Ex by dou Ez can be replaced with that value minus gamma Ex. Minus dou Ez by dou x is equal to minus j omega mu Hy. For further simplification, we can simply multiply the minus sign on both the sides. We can get gamma Ex plus dou Ez by dou x is equal to j omega mu Hy. Consider this as the seventh equation. And the last one, there is no change. We can simply write as such dou Ey by dou x minus dou Ex by dou y is equal to minus j omega mu Hz. Consider this as the eighth equation. So these 8 equations are very important to derive the field components of rectangular waveguide. First we are going to find out the field component Hx. For that, we are going to use the equations 6th and 4th, okay? From the 6th equation, that is dou Ez by dou y plus gamma Ey is equal to minus j omega mu hx. We can move this dou Ez by dou y to this side as a minus, and then we can find out this Ey value by moving this gamma to this side as a denominator. We can get Ey is equal to what now? Minus j omega mu by gamma hx minus 1 by gamma dou Ez by dou y. Consider this as the ninth equation. We are going to substitute this ninth equation in the fourth equation. So what is the fourth equation? Dou hz by dou x plus gamma hx is equal to minus j omega epsilon Ey. So here this Ey is replaced with this value. We can get minus j omega epsilon into Ey value is what? Minus j omega mu by gamma hx minus 1 by gamma dou Ez by dou y. Correct? We can multiply this minus j omega epsilon inside this bracket. Then we can get minus into minus plus j squared omega squared mu epsilon by gamma hx plus here it is minus into minus plus j omega epsilon by gamma dou Ez by dou y. As we all know that j squared is equal to what? Minus 1. In the next step, this minus becomes plus in this side. So here we can get gamma hx plus this term becomes plus omega squared mu epsilon by gamma hx is equal to this term j omega epsilon by gamma dou Ez by dou y. This term becomes minus in this side. So minus dou hz by dou x. Here we can take this hx as a common one. So this term becomes gamma plus omega squared mu epsilon by gamma that is equal to j omega epsilon by gamma dou Ez by dou y minus dou hz by dou x. Here we can simplify term further like this. Gamma squared plus omega squared mu epsilon by gamma is equal to this term. Here we can assume this gamma squared plus omega squared mu epsilon as a h squared value. So this is very important assumption over here. This value can be used in the characteristics as well. Okay. So h squared is equal to what? Gamma squared plus omega squared mu epsilon. Then this term can be written like this. H squared by gamma is equal to j omega epsilon by gamma dou Ez by dou y minus dou hz by dou x. Finally, we can get the value of this hx by moving this value to this side as a reciprocal term. Here gamma is already there. If we are going to move this term to this side as a reciprocal, this value is multiplied with this square, that is gamma divided by h squared. Gamma divided. Then we can get the value as j omega epsilon by h squared dou Ez by dou y minus gamma by h squared dou hz by dou x. This is the value of hx. Okay. So here this hx component in terms of Ez and hz. Okay. Similarly, we can find out the value of Ey component. For that, we can consider the fourth equation. From this fourth equation, dou hz by dou x plus gamma hx is equal to minus j omega epsilon Ey. Here gamma hx is equal to minus j omega epsilon Ey. This term becomes minus in this side. So minus dou hz by dou x. Then we can move this gamma to this side as a denominator. Finally, we can get hx is equal to minus j omega epsilon gamma Ey minus 1 by gamma dou hz by dou x. Substitute this value in the sixth equation. What is the sixth equation? Dou Ez by dou y plus gamma Ey is equal to minus j omega mu hx. So this hx can be replaced with that value. Then we can get minus j omega mu into minus j omega epsilon by gamma Ey minus 1 by gamma dou hz by dou x. We can multiply this value inside this one. So minus into minus plus j squared omega squared mu epsilon by gamma Ey. Here it is minus into minus plus j omega mu by gamma dou hz by dou x. Okay. Then we are going to move this Ey term to this side, because we are going to keep all the Ey terms in the left hand side. Here j squared is nothing but what? Minus 1. Then this term becomes plus in this side. So gamma Ey plus omega squared mu epsilon by gamma Ey is equal to j omega mu by gamma dou hz by dou x. this term becomes minus dou Ez by dou y. Here we can take this Ey as a common term. We can write the value as gamma plus omega squared mu epsilon by gamma. This term is further simplified as Ey into gamma squared plus omega squared mu epsilon by gamma. As we all know that gamma squared plus omega squared mu epsilon is nothing but h squared. So we can substitute that value here. Then this term becomes Ey into h squared by gamma is equal to j omega mu by gamma dou hz by dou x minus dou Ez by dou y. We can move this term to this side as a reciprocal term. Then this term becomes gamma by h squared. Similarly here it is gamma by h squared. So this gamma divided each other. Then we can get the Ey value as j omega mu by h squared dou hz by dou x minus gamma by h squared dou Ez by dou y. This is the value of Ey component in terms of hz and Ez values. Okay. Consider this as the 11th equation. Next, we are going to find out Ex and Hy field components using 3rd and 7th equations. So, first we are going to find out Hy component. For that, we can take that 7th equation. Dou Ez by dou x plus gamma Ex is equal to j omega mu Hy. From this, we can get gamma Ex is equal to j omega mu Hy. This term becomes minus in this side. Then Ex is equal to j omega mu by gamma Hy minus 1 by gamma dou Ez by dou x. So next we are going to substitute this Ex value in the 3rd equation. So what is the 3rd equation? Dou hz by dou y plus gamma Hy is equal to j omega epsilon Ex. So this Ex is replaced with this value. Then we can write j omega epsilon into j omega mu Hy by gamma minus 1 by gamma dou Ez by dou x. Okay, here we can multiply this value inside this bracket. We can get the value as j squared omega squared mu epsilon by gamma Hy minus j omega epsilon by gamma dou Ez by dou x. As we all know that j squared is equal to what? Minus 1. So this term is minus. In the next step, we are going to move all the Hy terms to this side. So here it is gamma Hy. This term becomes plus. Correct? So plus omega squared mu epsilon by gamma Hy is equal to, here it is minus j omega epsilon by gamma dou Ez by dou x. This term becomes minus dou hz by dou y. Here we can take this Hy as a common one. Then this term becomes gamma plus omega squared mu epsilon by gamma. Okay. Then further simplification, we can get the value as gamma squared plus omega squared mu epsilon by gamma. As we all know that gamma squared plus omega squared mu epsilon is nothing but h squared. So this term can be written like this. Hy into h squared by gamma is equal to minus j omega epsilon by gamma dou Ez by dou x minus dou hz by dou y. Then we can move this term to this side as a reciprocal one. That means here it becomes gamma by h squared. So gamma cancel. Here it is gamma by h squared. That's what given here. Finally, we can get Hy component is equal to minus j omega epsilon by h squared dou Ez by dou x minus gamma by h squared dou hz by dou y. So this is the value of Hy field component. Okay, consider this as the 12th equation. Okay. Finally, we are going to find out the Ex component in the same way. For that, we can consider the 3rd equation. Dou hz by dou y plus gamma Hy is equal to j omega epsilon Ex. Then we can get gamma Hy is equal to j omega epsilon Ex minus dou hz by dou y. Then we can move this gamma to this side as a denominator. That is j omega epsilon by gamma Ex minus 1 by gamma dou hz by dou y. Then we can substitute this Hy value in that 7th equation. What is the 7th equation? Gamma Ex plus dou Ez by dou x is equal to j omega mu Hy. So this Hy is replaced with this value. Then we can get j omega mu into j omega epsilon by gamma Ex minus 1 by gamma dou hz by dou y. Multiply inside this one. We can get this value. Here j squared is nothing but minus. In the next step, we can move this Ex term to this left hand side as a plus. We can get gamma Ex plus omega squared mu epsilon by gamma Ex is equal to minus j omega mu by gamma dou hz by dou y. This term becomes minus dou Ez by dou x. Here we can take this Ex as a common one. Then this term becomes gamma squared plus omega squared mu epsilon by gamma. As we all know that gamma squared plus omega squared mu epsilon is nothing but h squared, correct? So here it becomes Ex into h squared by gamma is equal to this term. So next we are going to move this value to this right hand side. Finally we can get the value of Ex component as minus j omega mu by h squared dou hz by dou y minus gamma by h squared dou Ez by dou x. Consider this as the 13th equation, okay? Finally, the equations 10, 11, 12 and 13 are representing the field components of electromagnetic waves propagating in the rectangular waveguide. So here the field components are Ex, Ey, Hx, Hy. Okay, so here you can remember these values. It is very important concept. From this we can find out the values of TM waves and TE waves. Okay, so these four equations are important field equations used in rectangular.